Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I hope you all fine and all is well. Dear students, here is Mrs. Saira Jamal with 13th lecture, and in this lecture we will continue chapter number 11, that is organic chemistry. In this lecture we will discuss the sources of organic compounds. There are two important sources of organic compounds, animals and plants. From animals, we can get proteins, fats, or oils. Then from proteins, like the sources of proteins are eggs, mutton, chicken, beef, and fish. And the sources of fats and oils are milk, butter, and cheese. The plants, sources of organic compounds from plants are, they may be live plants or dead plants. From dead plants, we get coal, petroleum, and gas, that is the natural gas. And from live plants, we get carbohydrates, proteins, vitamins, and oils. And the sources of carbohydrates are wheat, maize, potatoes, barley, and rice. Sources of proteins from plant origin are pulses and beans. And vitamin sources are apple, oranges, bananas. Sources of oils are palm oil, olive oil, soya bean, peanut oil, and sunflower oil. So all these are the sources of organic compounds from animals and plants, and also from live plants and dead plants. Sources of organic compound, in this case we will discuss the sources of organic compounds, and these are from the dead plants and dead animals. So the major commercial sources of alkanes are coal, natural gas, petroleum, and living organisms. So these are the main sources of alkanes. Coal is a source of many organic compounds. When coal is heated in the absence of air at high temperature, then it is converted into its components, and those fractions or those components are coal, gas, coal tar, and coke. This process is called destructive distillation, and coal is also used as a solid fuel. Now, what is destructive distillation? Destructive distillation is a chemical process involving decomposition of a solid by heating it in a closed container and collecting the resultant volatile constituent. Resulting volatile constituent means the resulting components which are formed after heating that compound. And destructive distillation involves the separation of components through decomposition of a solid. Decomposition of a solid means the solid breaks down completely and then give us some important components. So those components, we can say, we get those components by destructive distillation of coal. Then we, as I told you, that after the destructive distillation of coal, we get coal gas, coal tar, and coke. So coal gas contains methane, hydrogen, and carbon monoxide gases. It means coal gas is a mixture of these gases. Coal gas contains methane, hydrogen, and carbon monoxide gases. It is mainly used as a fuel in industry. We use coal gas as a fuel in industries. Then the second component, coal tar, it is a source of many organic compounds. Like you can get many organic compounds from coal tar, and those important compounds are benzene and its derivatives. These compounds can be separated by fractional distillation. How can we get these different components from coal tar? By the fractional distillation of coal tar, we can get these components. These are very useful substances in synthetic organic chemistry. Like we can synthesize many compounds from these compounds. These compounds are used to synthesize plastics, dyes, fibers, drugs, paints, varnishes, etc. And the residue left behind is called pitch, which is used to metal roads and roofs, like to make roads and roofs of it. As I told you about the coal tar, that the different components of coal tar are separated by fractional distillation. So what is fractional distillation? After the destructive distillation of coal, we get three components, and those three components are coal gas, coal tar, and coke. Then after the fractional distillation of coal tar, we get different components. So what is fractional distillation? Fractional distillation is the process used to separate hydrocarbon components in crude oil. So we can also use this method for the purification of petroleum, for the purification of coal tar. So it involves the separation of components according to the difference in their boiling points. It's clear that those compounds which has lower boiling point, they will boil out first, and then we can separate in a fractionating tower which is designed for fractional distillation. So in that fractionating tower, we can get different components of a mixture by difference in their boiling points. So in this image, you can see the destructive distillation of coal. That is, coal is completely decomposed by heating it and by keeping the test tube airtight. So in the absence of air, when coal is heated at a high temperature, it decomposed into coal gas, coal tar, and coke. So we can get this component by this method, which is called the destructive distillation of coal. Coal, I told you, after destructive distillation will give us a solid part called coke, the liquid part called coal tar, and a gaseous part or component called coal gas. So that coal gas, I told you, is used as a fuel in industries, and coal tar is used to make dyes, drugs, plastic, etc. And the solid coke is used to make iron and some other matter. So these are the three components which we get after destructive distillation of coal, and after the fractional distillation of coal tar, then we get other components like benzene and derivatives of benzene. Natural gas, second source of organic compound, like from plant origin, that is the dead animals and plants. They are buried under the soil, and after millions of air, due to high temperature and pressure under the earth, those dead remains of animals and plants, they are converted into coal, petroleum, and natural gas. So natural gas is a mixture of low boiling hydrocarbons. Low boiling hydrocarbons means that they contain less number of carbon atom, like methane, which contain only one carbon atom, ethane, two carbon atoms, propane, three carbon atoms, and butane, four carbon atoms. And we know that the hydrocarbons or alkanes from carbon number 1 to till carbon number 4 are gases. So natural gas is a mixture of low boiling hydrocarbons and or you can say simple hydrocarbons. Those simple hydrocarbons are methane, ethane, propane, and butane. Although the percentage of methane is more than 90%, the rest of the gases are present than less than the methane. The third source is petroleum. Petrol contains a wide variety of alkanes, including those having very long chains. On fractional distillation, petroleum separates into various components known as fraction, and each fraction is not a pure compound. Each fraction is also a mixture of different compounds that boils in a certain range of temperature. This is the fractionating tower where the fractional distillation of petroleum takes place. Petrol is first heated at a high temperature. This is the crude petrol, or crude oil means impure form of petrol. And that crude petrol, after heating in this furnace, is passed through this fractionating tower. This tower has different fractions in it. So definitely that component of petroleum which is lighter and which needs or which and the boiling point of that compound is very low, so that will boil first and will go to the first column, and then we can collect it through this opening. So this is the component where we can get the gases. Then after gases, in other words, you can say liquefied petroleum gas, which is also called LPG. LPG is collected in the first column. After LPG, naphtha is collected. After naphtha is gasoline, which we call petrol. After petrol is we have the paraffin oil. Then we have diesel oil, which are used for big automobiles or heavy automobiles. After diesel oil is lubricating oil, and then fuel oil, and then the last one is the residue which is left behind, and that residue is used to build roads and roofs. So the first one, LPG, which is called liquefied petroleum gas. You know that we use it for cooking purposes, like it provide us heat for cooking, and definitely for some other important gaseous uses. Then chemicals, then gasoline is a petrol for vehicles. I told you the paraffin oil is, or kerosene oil is used as a fuel for jet planes, and also we use it for heating. Then we use the diesel fuel for the big automobiles like trucks, trains, and buses, etc. And lubricating oil is used to lubricate or use in polishes or in waxes and to lubricate the machines. And then the fuel oil is used for ships and industries to run, or factories to run. And the last one, which is called bitumen, is used for roads and roofing, for making roads and for making roofs. So fraction decreases in density and boiling point, and a fractionating column. This column is called fractionating tower, in which different fractions of petroleum are separated out on the basis of difference in their boiling point. So as they have different boiling points, so that's why they are separated out by using this fractional distillation method. We cannot only use this fractional distillation method for petroleum, but we can also use it for the coal tar to get different fraction from coal tar, like benzene and derivative of benzene. The next source of organic compound is living organisms. So many important organic compounds such as proteins, fats, carbohydrates, vitamins, drugs, and medicines are obtained from plants and animals. Then next method is synthesis in laboratory. It means organic compounds are not all organic compounds are not natural. There are some organic compounds which are artificial and we can synthesize them in lab. One of the important example is urea. Urea is an organic compound, but it is synthesized in industries. So more than 10 million organic compounds have been prepared in the laboratories, and they are being used in medicines, cosmetics, detergents, fertilizers, paints, plastics, and in flavors, different flavors of food we are using these organic compounds. Then what are the uses of organic compound where we can use organic compound? So the one of the organic compound like source of organic compound like natural gas and petroleum are used primarily as fuels, and these are also used as a starting material for the production of variety of organic compounds. Then propane and butane, which are gases, and we obtain these gases from natural gas because I told you it is a mixture of these gases as well, and are widely available as liquid in fuel cylinders. And ethylene is the major starting material for the manufacture of organic chemicals and products such as polyethylene, which is also called plastic, ethyl alcohol, acetic acid, and ethylene glycol, which we use as an anti-freezing agent. Acetylene, ethyne, carbon-carbon triple bonded compound, which is called ethine, or also acetylene is used in the oxyacetylene flame, and that flame is used for welding and cutting metals. So acetylene is also used in the preparation of polymers like PVC, polyvinyl chloride, the plastic pipes, polyvinyl acetate, synthetic rubber, and nylon. So organic compounds are also used, especially acetylene is used for this purpose. Acetylene is also used for artificial ripening of fruits, the fruits which are transported to other cities or countries or areas. They are uh, keeping safe or preventing the fruits from ripening. These acetylene is used, and it ripens the fruit very slowly, and when it reach to its destination, then the after 2 or 3 days the ripening process of those fruits completed. So compound of phenol help to ensure antiseptic condition in hospital operating rooms. Phenol is used as an antiseptic to kill germs, and methanol is used as a solvent for fuels, oils, paints, and varnishes. Like mostly we use the methanol as a thinner or as a solvent. Many organic compounds are used in the manufacture of drugs, dyes, cosmetics, detergents and soaps, nylon, emulsions and paints, etc. All these dyes, drugs, paints are organic in nature. Next topic is about alkane and alkyl radicals. What are alkane? Hydrocarbon whose carbon-carbon bonds are single are called saturated hydrocarbon, and saturated hydrocarbons are also called alkanes. So in each alkanes, each carbon atom is attached with four other atoms. So if we have formula CnH2n plus 2, this is the general formula for alkanes. And what is alkyl radical? Alkyl radical is a group of atoms obtained by removing one hydrogen atom from an alkane. Alkyl radicals are represented by capital R, and general formula for alkyl radicals are CnH2n plus 1. Alkyl radicals are named by substituting the suffix YL for and in the names of alkanes. So if I suppose if I have butane, so when one of the hydrogen of butane is removed, it is converted into alkyl radical, which is called butyl. For N in the name of alkane from which they are derived, so remove A and E from alkane, and then instead of A and E, we will use YL. So butyl, pentyl, hexyl, heptyl, we will use these type of names. Example 11.3, converting alkanes into alkyl radicals. So we have to convert methane into methyl by removing one hydrogen atom from methane. Methane is converted into methyl radical. So you can see there are three hydrogen atoms over here. The valency of carbon is not satisfied because carbon always make 4 bonds. Ethane is converted into ethyl, like here we have C2H6, 6 hydrogen atoms, but after the conversion into radical, it has 5 carbon atoms and still 1 bond is required. Propane has 2 radicals, N-propyl and isopropyl. N-propyl and isopropyl, these are the 2 types of radicals obtained from those compounds or those alkane which contain more than 2 carbon atoms. For more than one alkyl group or more than 2 carbon atoms, then we use these 2 types of radical. For instance, like propane form 2 alkyl groups or radical, N-propyl and isopropyl. The group obtained by removing terminal hydrogen atom is called N-propyl. Terminal means from the start, from the tip. If hydrogen is removed from the tip carbon atom or from the starting carbon atom, then the alkyl radical form is called N-propyl. And if the hydrogen is removed from central carbon atom, then those compounds are called isopropyl. For example, you can see here we have propane, 1, 2, 3 carbon atoms. I told you, so we will use the term prop, and as all the bonds are single bond. Propane after removing hydrogen atom from the terminal means from the first carbon atom will give us N-propyl radical, and if hydrogen is removed from the center carbon atom, then this is called isopropyl radical. So not only propane but the higher chain, butane, pentane, hexane, all can give these 2 types of alkyl radicals. Self-assessment exercise 11.5. Derive alkyl radicals from the following alkanes. The first example is ethane. So ethane, after removing one of the hydrogen atom, is converted into ethyl radical, and butane, after removing hydrogen atom from the terminal, will give us N-butyl alkyl radical. And if hydrogen is removed from the mid carbon atoms from any of the two, from this one or this one, then this type of compound is called isobutyl radical. Another example is for propane. Propane will also give us N-propyl if the terminal hydrogen is removed, and isopropyl if the hydrogen is removed from the middle carbon atom. So it will give us isopropyl. Next topic, which is very important, is the classification of organic compounds. So organic compounds are classified into 2 main classes, acyclic or open chain compounds, and cyclic or closed chain or ring compound. Then open chain compounds are classified into straight chain and branch chain compound, while closed chain or cyclic or ring compound are classified into homocyclic or carbocyclic compound and heterocyclic compound. Homocyclic compounds are then further divided into alicyclic compound and aromatic compound, and but aromatic compounds are then further classified into benzonide compounds and non-benzonide compounds. So in your book, they explain only till homocyclic or heterocyclic compounds. Till here they explain. So the classification of organic compound is there are millions of organic compounds. It is not possible to study each compound individually. So to make their study easy, they are classified into various groups and subgroups. So it is helpful to pick out these compounds which have similar structure. So you will learn uh, uh, like uh, like in this topic or here, the classification of organic compounds on the basis of carbon skeleton. They are broadly classified into 2 main groups: open chain compounds or acyclic compound, and closed chain or cyclic compounds. In chemistry, an open chain compound or acyclic compound is a compound with a linear structure like straight chain. All the carbon atoms are attached in a line or in a straight chain. And if an open chain compound having no side chain is called a side a straight chain compound. As I told you, open chain compounds are of two types, a straight chain and branch chain. So straight chain if all the carbon atoms are arranged in a straight line. So you can see here that we have these example. Propane is straight chain, butane is straight chain, but isobutane is not a straight chain organic compound. One of the methyl group is present as a branch on this straight chain. So isobutane is the example of branch chain organic compound, and this is also branch chain organic compound, and the first two are the you can say straight chain compound. So open chain compounds are of two types, like close, another straight chain compound and branch chain compound. Is the compound having following structure an open chain compound? No, it is making a ring, so it is not open chain compound. It is a closed chain compound. Open chain compounds may be either straight chain or branch chain. So those compounds which contain any number of carbon atoms joined one after the other in a chain or in a row are called straight chain compound. You can see propane, butane, pentane, all the carbon bonds are single, and each carbon atom make four bonds. So valency of carbon atom is satisfied. Those compounds which contain carbon atoms on the side of chain are called branch chain compounds. Which of the following is a branch chain compound? So you can see this is straight chain compound, isobutane is branch chain compound, and neopentane is also a branch chain compound. Then closed chain or cyclic compound. Closed chain or cyclic compounds are organic compound which contains rings of atoms are called closed chain or cyclic compounds. For example, cyclopropane, it is a ring, then cyclobutane, a ring, then benzene, it is also a ring, and cyclohexane is also a ring. So all these compounds are closed chain organic compounds. So closed chain organic compounds are called cyclic compound, and which contain carbon atoms connected to each other in a ring, or they are called homocyclic because only carbon atoms are present in the ring. But if instead of any carbon atom there is any other atom, when atom other than carbon are present, also present in a ring, then it is called as heterocyclic organic compound, because this ring does not contain all carbon atoms. They also contain an atom other than carbon atom. For example, we have example of pyridine. You can see 1, 2, 3, 4, 5, 5 are carbon atoms, but the sixth one is nitrogen. So it is pyridine, and one of the carbon is replaced by oxygen, so furane. One of the carbon is replaced by sulfur, so thiophene. So pyridine, furane, and thiophene. These are called heterocyclic organic compound because they does not contain only carbon in their ring structure. They also contain sulfur, oxygen, and nitrogen in their structure. Dear student, self-assessment exercise 11.4 and 11.6 is your assignment. Heterocyclic compounds and homocyclic compound. I told you that organic compounds are classified into these main branches. Like the first two branches are the open chain compound and closed chain compound. Open chain compounds are also called acyclic, and closed chain compounds are called cyclic. Open chain compounds are then further classified into straight chain compound, where all the carbon atoms will be present in straight line. And branch chain compounds are those compounds which contain at least one of the carbon atom as a side chain or as a branch on the main chain. Then cyclic or closed chain compounds are also classified into two groups: homocyclic or carbocyclic compound and heterocyclic compound. Heterocyclic compound, I told you they in their ring contain an atom other than carbon atom, while homocyclic compounds contain only carbon atoms in the ring. So their properties are like the homocyclic compounds. So this was all about the classification of organic compound, sources of organic compound, alkane and alkyl radicals, and I hope you will understand this lecture. Inshallah, we'll meet you in with my next lecture. Till then, take care. Allah.